Hello and welcome to Shudge Thyru and Stan Campbell's Chemical Extravaganza. Or the video you gotta watch if you want to know a bit about chemistry? Chemistry.
Particle theory. Particle theory states that all matter consists of very, very small particles which are constantly moving or vibrating. This means anything as small as hair or greater than galaxies can be made up of particles. This theory explains how many things and substances work in the world. Why does iron rust? Why ice melts when being heated? These questions will all be answered in this video. There are 4 states of matter. These are
solids, liquids, and gases. Solids. Solids have a definite shape and they're hard to compress. The particles are held tight together and the particles are strongly attracted to each other. They may vibrate, but they still stay in an orderly fixed position. Liquids. Liquid particles stay fairly close together with some attraction to their particles. The particles slip and slide over each other,
which gives them a random order.
And gases. Gases have no fixed shape and they're easy to compress. They have very little attraction between the particles in them and are free to move around and collide with surfaces bouncing off them. They will space out to fill a container equally.
These 3 states are formations at which the particle can take. Now here's Stan to tell you about changing state.
Solid to liquid is melting. Liquid to gas is evaporation.
Gas to liquid is condensation.
Liquid to solid is freezing. Solid to gas and gas to solid is sublimation.
Now I'm going to show you an experiment that proves particle theory. This experiment is called the bromine experiment. First we got a container and put Vaseline around the lip of the container. This creates a gas-tight seal so that the bromine doesn't escape. Then bromine was added to the container. The container was then sealed, then we watched. The whole container had a brown gas, and the bromine had disappeared. What had happened, you may ask? Well, let me explain. Something called diffusion had occurred. Diffusion is the movement of particles from a high concentration to a low concentration. This happens because bromine has very little attraction between its particles. Therefore, it diffused. Now let's move on. Atoms and molecules. As I said at the beginning of the video, everything, and I mean everything, is made out of particles. These particles can either be atoms or molecules. Let's go into atoms. Atoms consist of 3 subatomic particles. These are electrons, protons, and neutrons. Protons are positively charged and are located in the nucleus. Neutrons are also located in the nucleus, however, they have no charge as they are neutral. Around the nucleus, there are shells. These shells contain electrons. The electrons are negatively charged. The different types of atoms are called elements. Each element is recorded on the periodic table. The elements are recorded in order of atomic number. The atomic number is the number of protons or electrons in the atom. The reason why it can be both is because most elements have an equal amount of protons to electrons. This means that the overall charge of the atom is neutral, as the charges cancel each other out. As you go across the periodic table, the number of electrons increase. As you go down the periodic table, the number of shells increase. Now, let's talk about molecules. Molecules are two or more atoms bonded together. Molecules can also be referred to as compounds and are not included in the periodic table. Covalent and ionic bonding.
Ionic bonding.
An ion is an atom with one less or one extra electron.
Ionic bonding is between a metal and a non-metal, where one of the two atoms, usually the metal, gives an electron to the other, one or more. Usually the one receiving the electrons is the non-metal. This is to satisfy both atoms' full outer shells. A good example of ionic bonding is when a sodium atom bonds to a fluoride atom. The sodium atom will give one electron to the fluorine atom. Now both have full outer shells, as the fluorine atom originally had 7 electrons. With the addition of 1, it now has a full outer shell of 8. The sodium is now an ion. It is 1 positive. The fluorine is also an ion now, being 1 negative. Because one's positive and one's negative, they're both attracted to each other, and so bond to each other. Covalent bonding. This is the name given to the type of bonding which happens between two non-metal elements. This is where the non-metal atoms share their electrons in pairs, as opposed to giving or taking electrons, such as in ionic bonding. Here are two fluorine atoms. The one on the left has its electrons represented by blue dots, and the one on the right has its electrons represented by red crosses. In the middle is where the two overlap. Now each of them have shared both of their electrons and have a full outer shell.
An intramolecular force is any force that holds together atoms making up a molecule or compound. In order to break that force, you'd need the same amount of force that made them. Here's another experiment with potassium permanganate. A day later, the permanganate had gone, and all that was left was a purple liquid. The permanganate had dissolved into the water, but you might be wondering, why did it take so long? This is because potassium permanganate is a giant lattice. This causes it to have strong intermolecular attractions. Giant lattices are pretty amazing. They appear to go on forever, and if each atom was the size of a human, then they would be tens of kilometers long. Potassium permanganate is ionic, therefore it has positive atoms and negative atoms. These atoms are called cations, which are positive, and anions, which are negative.
Metallic bonding. Metals are often found in everyday life of lumps of just metal atoms bonded to each other. Metallic bonding is often described as the strong attraction between closely packed, positively charged metal ions and a sea of delocalized electrons. Metal ions will form as an orderly package of positive metal ions, like this. These ions are surrounded by a sea of delocalized electrons. They sort of float around and cancel out the overall charge of the positively charged metal ions. Delocalized electrons are electrons in a molecule, ion, or solid, in this case metallic bonding, that are not associated with a single atom or covalent bond. These delocalized electrons explain why metals are such good conductors, because a current can be carried by those delocalized electrons.
solid to liquid is...
Hello.
Wait, should you explain? 1 and action.
Hello, I'm Stan Campbell, and in this video we're going to explain chemistry. All the way from the basics of chemistry up to complicated theories such as... Can't do it. These delocalized electrons that I talk about are in the... Solids are held tight together, and they're particles that vibrate strongly and...
Hello, I'm Shin Starr, and I'm going to be explaining particle theory.